All right, so now it's saving to RAM disk, and I'm pretty sure there's enough RAM to save the rest of the class, which is, we're basically 1/2 through the class already, so I think there's enough RAM space to do it. I just have to upload it before I shut down the computer. All right. And then we can see if I can still go to get to the file. Yeah, persistent user, home user. Save it into the RAM disk. Okay, so now I have no reliance on the flash drive anymore. Everything is saved to the RAM disk. I just cannot reset or reboot the computer until I actually save everything and upload it. And oh, okay, it completely forgot about sheet 2, so we have to kind of do that all over again. Sheet 2 is okay. Sheet 3 is the one that we are having a question about. Okay, so we go new window. Resizable. There we go. All right. So let's try to break this program, okay? Because there are cases where it's not going to work correctly, but not all the case, or not all the cases. This really goes to tell you it is better off if your program is not working entirely, but if it works most of the time, those are the most difficult problems. Okay? If you write the program and it consistently fails, it just doesn't work, it's not that bad, okay? Because you know right away the program is not working, and then you try to fix the program. This is a really serious problem, because unless you design your test cases appropriately, this bug is hard to catch. Okay, so what I'll do is I'm going to give you initial values that will break the program. I will make W 4, X4, Y2, and then Z is unknown. In this case, it will pick the wrong number to put into Z. This is my precondition. So let's go to line 1, and W is greater than X is what? False. W is greater than X is false. So that makes the entire conjunction false. So I'll just finish this part here. This entire thing is false. If that is false, where do we go? We go to line 3. Okay. So on line 3, we evaluate a different condition. X is greater than W is false, because they are the same, right? Well, I'm just going to write the entire thing anyway, but you can see that X is greater than Y is not even important, because if one side of a conjunction is false, the entire thing is false already. So this is false as well. If that is also false, where do we go? We go to line 6, which is a catch-all branch. Okay, if all the conditions are false, we'll go to line 6. What does line 6 do? It updates Z using whose value? Using Y. So the maximum of W, X, and Y, which in this case is 4, 4, and 2, ends up as 2, which is incorrect. So this is one test case that will catch this bug. The question is, if you only throw 4 darts, as test cases to this program, are you sure that your 4 darts will catch this particular problem? That's the question. The other way to look at this, since I was using the analogy of a dartboard and darts, it's like you might have some ants walking over the dartboard. Okay, let's say you have like 20 ants, tiny little ants on your dartboard, and you're throwing your dart across the room. Okay, and you're only throwing 4 of them. What are the chances that one of your darts will land on one of those ants?
Infinitesimal. Infinitesimal.
Very small, right? So you pull the 4 darts off from the dartboard. You don't see any ants on any of your darts, and then you say, no, there are no ants on the dartboard. Would that be a good conclusion? And yet, that is the conclusion that many developers, many software developers, draw when they only throw a few test cases at a program, and if the program doesn't seem to be broken, they don't see the bug. Well, an end is a bug, right? When they don't see any defects, then they will just say, "Oh, the program is fine," because none of my darts, landed on an ant, so the dartboard must not have any ants. Okay, so that's a fallacy there. Okay, it is not good reasoning. So we'll get to the point later on of try to prove an algorithm is correct, because it seems like we need some way to rigorously be able to prove that an algorithm is correct. It is doing what it is supposed to. Right now we don't have the tools to do it just yet, but later on we will. Yep.
So to correct the illogical flaw in this program, we should say as long as W, X, and Y don't equal each other.
Well, that's an easy way to fix it. So let's move on to try to fix the problem here. So this time I will change the file to correct. And the way to fix it, or one way to fix it, there are multiple ways to fix this program, is simply to change greater than to greater than or equal to. Okay? And that will fix the problem. So let's go ahead and look at this algorithm. Save it first. And look at the trace here. So we'll just go ahead and delete everything and start from scratch. Start with line 1. Now that we have greater than or equal to, W is greater than or equal to X is true. What about W is greater than or equal to Y?
True.
That's true as well. True and true is true. So this entire expression is true. Then you move on to line 2. And Z is now going to get its value from W, which is 4. And then we get the post. So this is correct. Okay, the maximum of 4, 4, and 2 is in fact 4. Okay, but this is a kind of tricky problem, because to spot the problem is not that easy. All right, are you guys doing okay so far? Okay, does everybody understand why the previous version was incorrect? Okay. And this is also, one of those cases to illustrate, to really, really illustrate missing that equal to. Instead of specifying greater than or equal to, if you just use greater than, it changes the behavior of the program just slightly, but enough to make it incorrect in certain cases. So details is very important when it comes to programming. Okay, extremely, extremely important, because you can make or break a program just by leaving out or including the equal symbol. Alrighty, so I'm gonna save this file, and then we move back to Moodle. Go back to this class, and go back to conditional statements. The last part here has to do with how do you write similar code in C, in C++. I'm not going to spend much time on this topic in this class. I'll leave it up to Damon or Iraj to do it in the following semester. Okay, because it really is tricky. Okay, when you try to translate something like this into C and C++, it's really tricky. All right. I did promise you some tricky cases a little bit earlier. Okay, so now I'm going to give you those tricky cases. It's not tricky if you can think like a computer. In other words, if you can execute a program the way that a computer can, it's not tricky. It's really quite mechanical and in a way boring. How do you know you're doing well in this class? This is a quick indicator that some people, that it works on most people. If the stuff that I talk about in this class is boring because you already know that, or you know what I'm going to talk about next, you're doing well in the class. You will see, you will see later on, how boring it can get, because I'm just going to do the same thing over and over and over again. Then you might think, but why do you even bother doing it? That's not teaching. Well, but I'm applying the same mechanism in different settings. I'm combining different things in different ways. but each thing in the combination is still operating the same way as it always has been. Okay, but in different settings, the interaction of these different elements may make the whole thing look like, wow, this is something that we haven't learned in the class. But when you look at each individual piece, it's the same boring piece that we have been talking about for the entire semester. Okay, so that's something that you kind of have to, pay attention to. Is how does it work? It's very mechanical, and every time something, a particular concept is explained, it should be the same way as always. All right, so let's go ahead and write a very confusing program. I cannot really say this program is right or wrong because I'm not going to tell you what it is supposed to do. So without knowing what it's supposed to do, you cannot really say whether it's right or wrong. Okay. And I forgot all the settings already because I did not boot from my other thing. And this is what will happen to you too. It will try to make the first letter capitalized and stuff like that. When that happens and you don't really like that, go to autocorrect under options, and just turn off all of these options except for use replacement table, and certain entries in the replacement table we can get rid of too, but we'll leave it to when it does happen. So else if x equals to 0, then z gets 2. Else if y equals, let's make that happen. Z gets 3. Else if x is less than or equal to y, then z gets 4. Else z gets 5, and if. So this is the algorithm that I'm testing, and I said this is a little bit tricky. So we'll go ahead and throw some test cases at it and find out whether it really is tricky or not. Now when I say something is tricky, it is tricky only if we read it like a human being would have, someone who is not taking this class. But it should not be tricky if you actually look at the mechanism itself, because it is very, very mechanical and very predictable. So we have comments, line number, 3 variables in this case, x, y, and z. Those are all the items that we need. And we'll start with a precondition. So each of the test cases, has to look like this. So I'm just going to be lazy, copy and paste this one here before I change it. All right. So this time, let's try something a little bit random. Okay, 2, 5, and z starts with a question mark. We start with line 1. All right. Can someone tell me, is that true or false?
Sure.
All right. Where do we go next?
Line 2.
We go to line 2, and what does line 2 do?
Make Z1.
Make Z1, and then where do we go next?
That's it, right?
Post. Yep, we are done, because we take one branch and we are done. All right. Actually, what I want to do is to change this comparison a little bit, make it greater than or equal to. It doesn't change this particular test case, so there's no need to worry about that one. And I will change the name of this program to confusing. All right, so we now move on to sheet number 3. And before we do anything else, copy and paste it into sheet 4. All right, so here's sheet